reciprocal and rational functions. This is a concept that you learned about back in Algebra 2 as well as in pre-cal. So it's more going to be about refreshing your memory about how to graph and the different properties of these reciprocal and rational functions. You will be dealing with your most basic that you see on the left. You will be dealing with your more complex, which you kind of dealt with in pre-cal, and you're going to be dealing with these type of rational functions that have slant / oblique asymptotes. So reciprocal function is a function that's in the form of y equals k over x. Of course, k cannot equal 0 because if it did, then it would just be a constant, and that would not be a reciprocal function. The graph of a reciprocal function is called a rectangular hyperbola. So those curves that are in the function, and that red one, because that is your most basic reciprocal function, those are called hyperbolas. Your different properties of reciprocal functions. Again, this is your most basic reciprocal function. It has two branches. It has a vertical asymptote as well as a horizontal asymptote, x equals 0 and y equals 0. Your domain is basically every place where the function is defined. You cannot have 0 in the denominator, so your domain is x such that x does not equal 0. And then, of course, your range is the set of y values just that y does not equal 0. Your horizontal asymptote is an asymptote that can be crossed over. Horizontal asymptotes more so describe your end behavior of a graph. So basically what's happening to the y values the larger that x gets. However, vertical asymptotes, you neither cross nor touch those because that is where the function is undefined, and we do not deal with undefined functions. Your more complex reciprocal functions are known as your rational functions. You have two different ones here. F of x equals b over cx plus d plus a, and f of x equals ax plus b all over cx plus d. These are the general makeups where a, b, c, and d all represent some type of number that represents your rational function. To find your vertical asymptote, though, for either one of the functions, it would just be x equals negative d over c, or if you recall, to find a vertical asymptote, you just set your denominator equal to 0. Okay? And essentially that is what you're doing. That's how x equals negative d over c is even found. Please make sure that it is in the form of an equation. It does need to be x equals. Without it, it's incorrect. Your horizontal asymptotes, there's two different types because they correspond with the two different functions above. For the one where the a is not a part of the numerator, the horizontal asymptote is y equals a, because that a represents a vertical translation of the original reciprocal function. So of course, anytime it's being translated up or down, that is going to move that horizontal asymptote, hence why the horizontal asymptote is y equals a. And then the one over here on the right, your horizontal asymptote is going to be y equals a over c. Anytime the exponents are equal to each other. Do you guys remember this from Algebra 2 and pre-calculus? Okay, anytime the exponents, the degrees of the numerator and denominator are the same, it's always the ratio of the leading coefficients. Hence why it is y equals a over c. Some more basic information. Hopefully you haven't forgotten how to find an x-intercept. Of course, you set y equal to 0, and then you solve for your x-intercepts. When you set any rational function equal to 0, basically the denominator cancels out, and you're just left with your numerator. So a shorter way, instead of plugging in 0 for y, you can just set your numerator equal to 0. And then, of course, to find your y-intercepts, you set x equal to 0, and then you solve for y. And again, just in case you didn't hear me the first time, to find your vertical asymptote, you set your denominator equal to 0. Okay? Those are your different properties when it comes to rational functions. Here are your two other types of functions that you are going to be dealing with. Okay? These are your more involved ones. As you can see for the one at the top, you basically have a higher order polynomial in your denominator than you do in your numerator. In your numerator, this is just an example, you have a linear function. Your denominator, you have a quadratic function. Okay? How would I find the vertical asymptote with that one on the top? Set what equals 0? You say your denominator equal to 0. Yes, that has not changed. No matter what, you will always say your denominator equal to 0 because that is the point where the function is going to be undefined. So you say your denominator equal to 0, and so if it is indeed a quadratic, then you're going to need to probably factor quadratic formula to find out what are those values that make the denominator 0. Okay? However, to find your horizontal asymptote, since the degree of the numerator, which is 1, is bigger than the degree of the denominator, which is 2, your horizontal asymptote is, who remembers? Say again? It does equal 0, always. Anytime your denominator's degree is larger than your numerator's degree, then it's always y equals 0 for your horizontal asymptote. And the last type is when it's the reverse. You have a quadratic in your numerator and a linear function in your denominator, or a higher ordered polynomial in your numerator than your denominator. Okay? Still, to find your vertical asymptote, what will we do? So that will be dx plus e, or whatever's in the denominator equal to 0. And then, of course, don't forget vertical asymptotes are always in the form of blank equals. X equals, no matter what. It's always x equals, whatever your solutions are, x equals. Please make sure that they're equations, not just the number. However, in these types of cases, when it comes to your horizontal asymptote, there is none. Okay? This is when you'll deal with a slant asymptote or an oblique asymptote. And it really kind of just depends on which version of IB textbook you look at. Some use slant, some use oblique. But basically, it's a non-constant asymptote. So it could be a linear function. So you'll end up graphing a line with a slope and a y-intercept. It could be a quadratic, okay? But to basically find the slant or oblique asymptote, when you do have these types of situations, you are going to have to use division, polynomial division, like synthetic or long division, okay? So really it's kind of pulling back from some older concepts from a previous class, okay? So we're going to look at a handful of functions together to refresh your memory, and then I have some IB examples after the first two. So we're going to consider the function y equals 2x minus 6 all over x squared minus 3x minus 4. We are basically going to find all the information about it, x-intercepts, y-intercepts, horizontal, vertical asymptotes, and we're going to graph it, okay? And you'll see the types of problems that IB will ask of you when it comes to rational functions. Do realize that these are some of your more basic functions that they can ask other things, such as derivatives and integration. We're not there yet. So some of these problems, they may be short. That's because it was like a part A or B that dealt with this information. It's like C, D, E, and F that deal with other things. So let's start off with our most basic thing. Let's find our vertical asymptote. How would I find my vertical asymptote again? Set the bottom equal to 0. Now this is nothing but a quadratic, so I'm going to have to do what to find those? Well, I have to factor to find those vertical asymptotes. What two numbers multiply to give me -4 that add together give me -3? So in this case, looks like I'm going to have two values that are going to make my function undefined, which means I'm going to have two vertical asymptotes when I graph this. Where are they going to be located? X equals 4 and x equals -1. Okay? I'm doing your more involved rational functions. I'm not going to give you the simple basic one to do as a class because, I mean, you've been doing that. Okay? You've been doing that. I want to give you ones that are harder. Okay? What about my horizontal asymptote? Do I have a horizontal asymptote? Sorry, let me rephrase. This one is 0. Why is it 0? Because the bottom exponent is bigger than the top one. Very good. Okay? So now I have my vertical, horizontal asymptote. Let me kind of go ahead and start making a graph with all this information in it. So I have two vertical asymptotes at positive 4 and negative 1. How do vertical asymptotes look? They are dotted lines, dashed lines. Please make sure that they go through 4 and through negative 1. Okay? And I'll have a horizontal where? Y equals 0. Now, if you happen to have this on like a test or something like that, and the graph is given to you, you want to make sure that, as you can see here, I've gone beyond the given axis that I did draw. You will want to do the exact same when you're representing your horizontal asymptote if it so happens to lie on an axis. Okay? Let's find an x-intercept. Let's find an x-intercept. I want to set the numerator equal to 0. X equals 3, so it's going to be the coordinate 3, 0. And as you can see, 3, 0, yes, it is on that horizontal asymptote. Remember, you can cross over a horizontal asymptote. You can cross over a horizontal asymptote. It's the vertical ones that you can't cross over. And this just so happens to be one of those that it does cross over. What about my y-intercept? You plug in 0 to all the x's. So that leaves with negative 6 over negative 4. 2 negatives make a positive. So, and reduce that becomes what? So you have 0, 3 over 2, which is in between what two numbers? 1 and 2. Okay? So, now we have to graph this. Okay? We got all the information. At this point, now we can go ahead and graph the rest of this function. Okay? Now, back in algebra 2, back in pre-cal, your teacher probably told you, okay, so just pick some points now in each one of the regions so you have an idea of where the curve lies, okay? Because the graph is going to have to go through that point, and it's going to curve close to your vertical asymptotes and, continue to approach your horizontal asymptotes and things like that, okay? In the middle, you already know, or you should already have an idea of what this graph should look like, okay? So, what's the number that's to the left of the negative 1? Negative 2, okay? So that means I can plug in negative 2 to all my x's and figure out what my curve is there. But to be honest, they're not so concerned about these other random arbitrary points. It's more so, does it lie in this bottom area underneath the horizontal asymptote, or is it above the horizontal asymptote? So when you plug this number in, it's not about what is the output of y. It's more so, is it positive or is it negative? It's above that line or below that line. If I plug in negative 2, is that going to give me a negative number or a positive number on my numerator?
Negative 10 on your numerator.
It's going to give me a negative 10 in my numerator, okay? So I'm just going to write that up here. And if I plug in a negative 2 into my denominator, is that going to give me a positive number or a negative number? Huh?
Positive?
It's going to give you a positive number. What's a negative divided by a positive? A negative. So at negative 2, you are going to be in the negatives, which means you're going to be below that horizontal asymptote, which means your curve is going to be in that general area. Now, again, I could so plug that in and figure out exactly what is that point, so then I know for sure it has to go through that point, but they're not concerned about these arbitrary points, x-intercept, y-intercept. Yes. The other ones, not so much.
So do they want us to, show us plugging a number in, or can we just draw?
One of the things they might ask for is called a sign diagram, okay? And I was actually about to create it as we went through the rest of it. But a sign diagram is basically where you represent and you kind of show what is the values of what are the y values at each one of these critical x moments. So a sign diagram will basically consist of all your vertical asymptotes and the x-intercepts you have. Okay? So I have a vertical asymptote at -1. I have an x-intercept at 3, and I have another vertical asymptote at 4. And we just determined, based off of plugging in -2, that the y values, any y values that are going to be to the left of -1 are going to be negative. Okay? Now, in between -1 and +3, we should already know what the y values are going to be, because our y-intercept is in that area. And what was our y-intercept? Positive. That means that if I were to plug in 1, or if I were to plug in 2, it would give me a positive output, which means that the part that's before 3 and my x-intercept is going to be above the x-axis. All the y values are going to be positive, no matter what x value I plug in. If I plug in a number between 3 and 4, is that going to give me a positive or a negative? It's going to end up giving you a negative, because if I plug in 3.5, right? 3.5 times 2 is bigger than 6. So it's going to give me a positive number at the top. But if I plug in 3.5, when I square it, it's not going to be bigger than a negative 3 times 3.5 and a negative 4. So I have a positive over a negative, which make a negative. Again, if you're unsure, by all means, you are more than welcome to plug in these points, get their respective y values, and then plot them based off of that. But you're timed. Okay? Gotta think quickly. And then the last one would be, what's on the other side of 4? Give me a number on the other side of 4. If I plug in 5, 5 times 2 is 10 minus 6, that's going to be, it's going to be positive. If I plug in 5 here, a positive divided by positive is a, so that means that this part of the graph is going to be above. And that is your graph of 2x minus 6 over x squared minus 3x squared. Using no technology, of course. So this will be on like a non-calculator question.
So your sign diagrams is like, if you do it, it's gonna show you what your, like, whether your y's are gonna be either positive or negative between your vertical asymptotes and your intercepts.
Correct. Because those are like the major like points of the x-axis of your domain that are going to affect your y. Okay. Let's look at an oblique one. Refresh your memory about long division. All right, we're going to consider the function y equals 2x squared plus 3x minus 9 all over x plus 2. Our vertical asymptote is going to be what?
-2.
That is the numerical value, but we're going to write it as an equation. X equals -2. Again, you get your vertical asymptotes because you do what? You set your denominator equal to 0. Now, as for the other asymptote, it's not horizontal because the numerator's degree is bigger than the denominator's degree. It will be slant or oblique. You'll need to use long division or synthetic division. Now, one thing I noticed is that I don't think synthetic division is taught on like the international level, because every IB textbook I looked in is all long division. Okay? Long division is like what the quadratic formula is for solving quadratics. It always works. Synthetic division does not always work. Okay, synthetic division only works when you have situations like what we have right here, x plus 2, or an x minus 3, a linear function, where x is just x, not 3x or something like that. Okay? So I'm going to spend the time kind of refreshing your memory about long division. Okay?
Here we go.
So here we go. What goes underneath the division symbol?
2x squared plus 3x minus 9.
Very good. What goes on the outside? And to divide these two polynomials, you ask yourself, what times x will give you 2x squared? 2x. So, again, you only ask yourself, what times this first term, which is x, would multiply to give you that first term underneath the division symbol, and that's 2x. Then you multiply that 2x by the entire divisor. 2x times x is, and then x times 2x, 2 times 2x is, technically it's a positive 4x, but since you are doing division, you are going to need to subtract. You're going to need to change the signs, okay? So you're going to need to change the signs of every term in that blue line to cause your first term to cancel out. That is what you want, okay? So now you have 3x minus 4x, which is negative x, and then you bring down your next number, which is negative 9. And you repeat. What times x is going to give you a negative x? Negative 1. A negative 1 times an x is a negative x. Negative 1 times 2 is a negative 2. And then, of course, you can't forget, what do you have to do? Switch the signs. So this becomes a positive, this becomes a positive. My x's cancel out, and I'm left with negative 7. What is negative 7? It's your remainder. But we're not concerned about that, okay? That remainder is not going to have any effect on the graph when we graph this. Our oblique, or our slant asymptote, is going to be that quotient, y equals 2x minus 1. And that is what we graph on our graph. It is a line that has a y-intercept of what? Negative 1 and a slope of 2. So I'm going to go ahead and put in what I have so far. I have a vertical asymptote at negative 2. And now I have a slant asymptote at 2x minus 1. As you guys described, I start at negative 1. Then I go from here up 2 over 1. Up 2 over 1. Up 2 over 1. I wish I had a grid. Or, for my y-intercept, instead of going up 2 over 1, I could go down 2, left 1, down 2, left 1. There's the intersection of the asymptotes. Down 2, left 1, and then I connect them. I should have put it in the graph there, but change it now. Roughly. Okay? Well, let's see based off of our x and y intercepts. Let's find those first. Okay? How do I find my y-intercept? Well, when I plug in 0 and I simplify, what do I get? So negative 9 over 2, which is in between what two numbers? Negative 4 and 5. So the fact that that point is there, that means that that rational function is going to kind of be in that like side right area. What I want you guys to do now, take a minute and I want you to find the x-intercepts. Remember, you find the x-intercepts by setting the numerator equal to 0 or plugging in 0 for y. You are going to need to factor this. I do want you guys to factor and find my x-intercepts. What were my x-intercepts? Negative 3. And then what was the other one? 3 over 2? Okay, cool. So then we have negative 3 and then 3 over 2, which is in between 1 and 2. For this one, do you see where your curves are going to be? They're going to be on those two side regions. That one is going to go through your y-intercept and your x-intercept and get very close to both your, oh, it's not going to be smooth. Going to be very close to your slant and your vertical asymptote. Try to make the smoothest curve possible. Please make sure you definitely go through those points. The smooth curve? Yes. Please make sure that when you make that commitment, that smooth curve, like once you start drawing, you don't like pick up your pen and try like to, smooth. And only go one time, okay? Don't do like the, you know, some of us like go back through like one more time, like, okay, let me just make sure it's there. No, don't do that. Because now you done created like a double line and you don't want to do that. I'm going to go ahead and erase that. And there you go. Okay? Those are your more complex rational functions. Okay? Y'all are going to be dealing with all of them, okay? Not just your simple ones, but all of them.